Today's lesson is on polynomial graphs, mostly the higher order we'll go through. We will talk about things such as turning points, number of solutions, the degree, end behavior, all that good stuff. All right, we're going to start with our basic y equals x. It makes a straight line. This is considered a first degree polynomial. Well, let's make this where you can not clutter up the screens quite so bad. It's a first degree. Now notice it doesn't have any bends in it. It crosses the x-axis one time. So we have at most one solution. And it has no turns. Now, if we want to go to our second degree, let me get that one up. All right, if you look at this one, this is y equals x squared. It is a second degree because of the exponent is 2. You can see pretty easily it has one turning point, meaning the graph is going down, hits this point, and it goes back up. It also can cross the x-axis at 0, 1, or 2 places. So we say it has at most, and that's why we always add that at most, 2 solutions and 1 turning point. And this turning point is also going to be your relative max or min. So this one would be a min because it's the low point. All right, this one is called a cubic, and you can see it's x to the third power, so that makes it a third degree. And if it's a third degree, that means it can cross the x-axis up to 3 times, so we can have 3 solutions at most, and it can have 2 turning points. Now this is where it can get a little confusing because it can definitely have less. So let me see if I could draw something else for you. So if we had something that looked like this. Oops, that one's not gonna. Okay. So if you notice, this is the same basic shape, but this area right here is a little more pronounced. It's going to cross the x-axis at 2 points. So it's crossing it here, here, I'm sorry, 3, here. So there are 3 solutions to this one, whereas this one only had 1 real solution. Still a third degree. This one could be what's called a repeated solution. And if you notice, we have 2 turning points. And our turning points are right here and right here. So we're going up, we hit that point, then we go down, hit that point, and go up. So that's what I mean by turning points. This one at the top is a max because it's a relative maximum. It's a high point. This one is a relative min. That's a low point. All right, we're into a 4th degree, and these get interesting because they can look really different. This is a 4th degree, so it can have at most 4 solutions. Now, the way it's written here, it's flat right here through the middle. However, you'll often see these graphs, so they look like this. And that means we have some opportunities for solutions. We have 1, 2, 3, 4 solutions, but if you notice, we have 1, 2, 3 turning points. And those are going to be your maxes and mins. Now, on your even graphs, both the ends go in the same direction. That's really important to remember. All right, and finally, x to the 5th. This is a 5th degree. It looks a lot like the cube, except again for this behavior right in here. If I wanted to, I could draw it like this. And what's going on is with each added degree, we're adding another dip in the middle. So every time it crosses the x-axis, that's a solution. So this one has 1, 2, 3, 4, 5 solutions, and it also has 4 turning points. And those will again be maxes up here and men's down here. Now notice on your odd functions, the ends go in opposite directions. That's going to help you with your identifications. So some things to remember on your polynomials. If n is the degree, that means you can have n solutions at most. You can always have less, and we will talk later about they can be imaginary, they can be real, they can be repeated, and you're going to have n minus 1 terms at most. And you can have your n behavior will either both go the same way for evens or opposite for odds, and we will get to that shortly. That's all for today.